About a locus question, they give you 1 point and then the center directly. They ask you to find out the equation of C. This one is the same here. Just ask you, do you remember the equation of circle? So now there is a circle. The center G is 0, 3. And then we have point A, 6, 11. So in part A, the equation of C, the criteria of circle is the distance from center is equal to radius. So in your brain, you should create a general point to represent all the points in this circle. And then for simplicity, we consider the whole thing square so that we don't need to care about the square roots. So here is x minus 0 square and then plus delta y, that means y minus 3 square, is equal to the radius, that means ag square. So x squared plus y minus 3 bracket square, and then here we just need to calculate. Because a passed through the circle, 6 squared minus 0 squared, and then plus 11 minus 3 squared. This is 6 squared and then plus 8 squared, which is 1000. So this is the equation of circle. We finish part A and then we focus on part B now. In part B, they say that P is a moving point such that AP is equal to GP. That means there are some possible position for P in between A and G so that PA and PG have the same distance. Some example is the midpoint directly, so this is the first possibility. Or a little bit further away so that these two are the same distance to form my isosceles triangle. So also here, maybe like this to have the same distance. So this will be a straight line finally. And then if you have enough calculation during lesson, you'll find that we are talking about a perpendicular bisector. You already know that this is perpendicular bisector. So you may try to solve the perpendicular bisector, or you start from the condition here. So now I'm going to show you how to start from the condition here. Again, we are going to write down the equation of inverted L. Then we need to use a general point on this line to represent L, which is, we are not talking about the circle anymore. We are talking about this line only. And then the requirement is AP equal to GP. And beware that A is 6, 11, G is 0, 3, P is X, Y, the general point. So AP is square, again, we don't want to handle the square root, so we take square on both sides. And then first we compare A with P, so this is X minus 6 squared, and then plus Y minus 11 squared. Is equal to GP squared. That means now we are comparing G with P. So X minus 0 squared plus Y minus 3 squared. About this polynomial, there are some square. You just handle it very carefully without making any mistake. Then you get a linear equation, which is our answer. So x squared minus 12x plus 36. So you'll find that both sides we have x squared and y squared. Both sides minus x squared, both sides minus y squared. And then we rearrange all the terms are in right hand side. And then we have to simplify it, both sides divided by 4. So 0 is equal to 3x plus 4y. and then minus 37. That's the answer for part B1. And then in part B2, they just describe the geometric relation. If you have enough practice before, then you should know that this one is perpendicular bisector. The line inverted L is the perpendicular bisector of line segment AG. Don't just say it's perpendicular bisector, say that it's perpendicular bisector of something, okay? After that, if inverted L cuts this C, C is meaning the circle. Don't forget it, they say that circle C. So this circle is called C. This line is called inverted L. Cut at 2 points, which means that 2 points, this point is called Q. This point is called R. We have to find the parameter of the quadrilateral AQRG. This is a four-side shape quadrilateral. We have to find the total length of all edges here. That's our mission. Before we started, they say 5 marks, and then you know that around 2 marks and 1 marks here. So this question only deserves 2 marks. It shouldn't be too complicated. And then you look at this graph, you know this one is R, the radius. And if you focus here, this is 10 square. So R is equal to 10. This length is also equal to 10. But now is what's the relation between this line and this line? You may consider the triangle with a right angle here. So this is right angle, and then we have a common side with the same length. So this triangle and this triangle are just congruent. The reason is SAS. The sides are the same, one pair, and then one pair of angle both 90 degrees, and then A here. So that's why this is equal to this. This is 10 also. Similar reason, this is equal to this. This is also 10. So this quadrilateral is a rhombus, and then we can make a conclusion. First, we know that QG is radius. Therefore, QG equal to 10. And then we know the fact that QA equal to QG equal to AR equal to RG equal to 10. You don't need to prove because only 2 marks here. Don't spend too long time here. Therefore, the parameter is 40 units. Finish.